Good morning, people. This is lecture 8, activity number 1 on March 7, 2023. Today, we're going to be starting the analysis of assemblies with solid elements. So, the situation is as follows here. You're told that there's an assembly like that. This is not a single part. It's an assembly made of three parts. It's the triangular bracket and the two pins, which are maybe purchased, and then there is a very small tolerance between the two. You insert it symmetrically inside of these two holes, and then clamp the end faces. The end faces of the two pins are clamped, and then a pressure P is applied on the top face of this triangular black bracket. Now, the expectation is that as soon as you see this, you should realize that at least in the context of this course, these have to be uh, modeled with solid elements or tetrahedral elements. Now, if somebody did this problem with as an assembly of the triangular bracket and these pins properly modeled with beam elements, I don't expect you to do that, but if you go that route, it better be completely correct. Okay. Otherwise, right now, we know that this is an assembly of three parts, solid parts, and they interact with each other in a sense that the periphery of these pins are in contact with the inside surfaces of these holes. Okay. You don't want to fasten them. You don't want to think about it as rigidly fasten them or even unrigid. Okay, fastener is generally unrigid, so you don't want to do it like that because you're told that these are inserted symmetrically inside of those holes. Okay, so let's go ahead and do that. My approach to these problems, by the way, you're expected to use as many planes of symmetry. So you should realize in this particular problem, there's only one plane of symmetry, and that is cutting the bracket through the thickness. Of course, when I say the bracket, the pins also. My approach to do these simple problems is a top-down approach. In other words, I make the bracket in the product, and while I'm in the product, I make the pin, and make the bottom pin. Although they're identical, I can use it twice as an instance or as a copy, but I will make them three independent parts. Okay, good. So let's go ahead and do that. I already have a product file opened up, so immediately I save this thing without having done anything. So file, save management, save as. I have a folder. I have a folder here. Let's see now, called Lab 8 and Activity 1. So this product is going to be saved in that folder. Okay, so just to make sure that I don't uh, I do these things properly, I'm going to say product activity 1. How about that? Activity 1. Okay, good. So at the end of every single one of these things, I add the activity. Good. Now, we will go and insert our first part. Insert a new part in there, and I'm going to call this thing right-click properties. I'm going to call this thing uh, bracket. This is the instance name, of course, and the part name is over here, bracket. Okay, good. Let's make it. So on this, to get into part design, notice that we are in assembly design, double gear here. To get into part design, you double click on the second line here. See, this has two gears on it. You can see that. Therefore, it has something to do with assembly. If you want to go to part design, you have to expand the tree and click on the line item, which there's a single gear on it. Double click on it, and you're thrown into the part design. Now this is generative shape design because the last time that I did something was in there. So let me switch from here to mechanical design and part design. So now we are in part design and we can make our part. So on this vertical plane, I will sketch. Now on purpose, by the way, I am going to make the entire assembly and then cut it. Okay, I'm not going to do make half of the bracket and half of the pin, etc. On purpose, I'm going to make the full model and then cut it. So let's see now, 10 inch by 5 inches. So let's go 10 by 5. So let's do it like that. We'll clean it up in a minute. Okay, let's put dimensions here. So this was 10 inches. I'm assuming this is made out of steel, by the way. So 10 inches, 5 inches here. 5 inches. Okay, this is almost a bracket, except that I have to put those holes in it. And these holes are diameter 1, 1 and 1, and 2 and 1 away. So, okay, so let's do a circle here, right there. Oops. Fit, fit. Oh, not multiple views. Sorry. There, let me do it again. Good, good. This is multiple windows. This one that I inadvertently clicked was multiple windows. Let's dimension these things. So from here to here is 1 inches, and from here to here is also 1 inches. From the center to there, 1 inches. Let's give this thing a diameter of 1. Okay, let's do the other circle. The other circle is over here. The dimensions of it from there, this point to this point, it is 2, and the diameter of the circle itself is 1. Okay, exit, pad it, and I'm going to do it in both direction, and the reason is that later on I want to be able to easily cut it with the middle plane. So mirror extend, but the thickness is 0.5, which means 0.5 in one direction, 0.5 in the other direction, for a total thickness of 1 inches, which I believe that's what it was. Even if it doesn't say here, oh yeah, the bracket thickness is 1 inch. Okay, good, good. Now, let's save this thing. Now, the way I do these things, if I go to the top level, if I go to the product right there, top level, and if I click on this floppy, then this part, which is called bracket, is going to be saved in that same folder with the name bracket. So let's check it out. That. Let's check that folder. I think that folder was yeah. Let's go up here. Yeah, I have a folder called Do Not Delete. It must be Do Not Delete. Do Not Delete. Uh, Desktop. Much. Oh, Do Not Delete. Do Not Delete. So must be this. Right there. You see that? I only saved bracket, which is right here, but the way I did it by going to the top level, clicking on the floppy, it also saved the bracket in that same folder. From now on, anything I want to save in here, or doing this work, I just click on this bracket. Now, keep in mind that there are other ways of doing it. The proper way of doing it is save management, and you can rename it, etc. You can select a directory, another directory if you want, etc. But this is how I did it. So now we go insert a new part in there, uh, and I always say no to this thing because I always use a new origin. I suggest that you read those comments, make sure it makes sense. I'm going to change this thing properties, change it to top pin. Top pin. top pin, say okay. This is the part number, or what Catia calls part number, we call it part name, and this is the instance. Okay, good. Now to make it, you double click on the top pin. You on that vertical plane, I will sketch. Now a circle that size, but the easiest way is to project that circle. Where's the projecting? Right here, project that top circle. So notice that it is projected, and I exit and I pad it in both direction, mirror extend by the amount that you're supposed to. The length of the pin is pin of 3 inches long, so 1.5 in each direction. So 1.5 to the right, 1.5 to the left. There we are. And go all the way to the top. Click on the floppy. It's going to save it in that same folder on the top pin. If you want to do anything else, you go File Save Management. Okay. Now insert a new part. Say no. Right click, Properties, bottom pin, bottom pin, bottom pin, bottom pin. Say okay. Make it. So we import design for making the bottom pin. So on that, I do exactly the same thing. Notice that this is identical to that. So I could have done copy, paste, or insert, save it, and then insert an existing component being the stop pin, but I'm doing the long way, hard way. So make it again. Once again, project. The choice is entirely yours on how you want to do it for your homework or how you want to do it as your test. We don't care as long as you do it right. So right meaning you get the final answers in stresses and things like that. All right, that's good. Okay, so go all the way to the top, click on the floppy. Everything's going to be saved there. Now, uh, because everything is made out of steel, I can go ahead and click on the apply material, select metal, out of steel, on the top level. So all three parts are going to be made out of steel. If these are different material, then you have to go to the part and apply individually material properties. Okay, that takes care of it. We are done. Notice there are no assembly constraints here. If I move these pins, if I move these pins or the bracket, they're going to stay in the move configuration. And if that's bothering you, or if that's not what you want, you have to put constraints on it. Okay. Let me go ahead and do that, although I don't need it for that problem. For this problem, it's a simple enough problem. I don't have to move these things, but just in the event that you have to move, actually, I'm not going to do that. I have already done it in the lab, or I will do it in the lab during my live presentation, and I'll worry about it then. I can't do everything here. Now, there is a split here in the assembly design. This is the assembly design workbench. There is a split icon where you can split assemblies with it. These things I don't want, so I'm going to close these windows that I never use. Oh, there you go. There's a saw here, right there. This I don't use either. And yeah, that one is okay. So click on the saw, and notice that it's not doing anything. If you look at the bottom left corner of your screen, it says select a plane or a face or a surface or an existing split. So I want to split with respect to that. And it says, hey, when you split this assembly with that plane, these are all the parts that are affected. Are you sure you want to cut all of them? The answer is yes, do them all. And it doesn't matter which side I pick. There we are. Okay. Now, you can always get them back by undoing it one by one. For example, let me see if I deactivate these, deactivate, then this is going to come back. The whole thing is going to come back, but I want to activate it, right? Good. That's pretty much it. So let's save everything. Good. So now we're going to go to the usual analysis and simulation, generative structure analysis. Catia sees three parts. Catia sees three parts, and if you mesh them one by one, all three of them are done. The size of these elements depend on the size of the part itself. So you don't have a direct control, but you can go change it if you want. For example, I can go to this one, hypothetically, and take the circle right there, this top pin, and double click on it and change it from point 0. If I feel that this is too small, so I go do, for example, do a point, I don't know, point 1 maybe. Didn't make that much of a difference. Try it again. This the one. Let's make it point. I don't know, point 2. See, it got bigger. Oh, this one also point 2. Remember, doing these things blindly means useless. It's totally useless. You really have to do a mesh conversion study, something that we are avoiding in this course. But if you get paid to do this, you have to do mesh conversion study. So let me make that guy bigger, maybe smaller. Sorry, point 4, right there. Okay, so if you want to make it small, even smaller, point 3. These are parabolic element. In the absence of any instruction, use linear with default material property, default size, I meant. Okay, good. If you want to see the mesh, no problem. Right click mesh visualization. There we are. Change the rendering right there. All right. Deactivate the mesh, do the rest of the problem. Okay, so let's go and take care of the symmetry planes. Surface slider, the bracket, the surface of the end of the place in the pin where we made a cut. See that? You have to do this, otherwise it's going to be wrong. And the same thing down here. I put them all in the same uh, placeholder. Here's the placeholder right there. See that? Put them all in the same place. You could have done it separately. It's up to you. And then these ends are clamped. So this is clamped and this is clamped. Okay. And this top face is subjected to a pressure of 100 psi. Now, remember, you don't divide 100 psi into to half divided by 2 just because you took half of the part. If it was a force, that's a different story. But pressure stays the same. All right. That's pretty much it. Now, file save management. If you click on this floppy, it's at the analysis. Then you have to go and select, the proper folder. But if I do file save management, I don't have that issue. File save management, everything else has been saved except for the analysis file. Save as in that same folder, lab activity. I'm going to say in that lab activity analysis 1, activity 1. As long as we can mark your paper, we don't care how you do it, but it's very easy to overwrite things because there are multiple parts here and there's a product. So these things all add up to complexity of the things that you beyond what was done on the midterm. That's pretty much it. So let's run it. And I don't anticipate any problems. This is the common message that you get, warning message, which we ignore. Ah, okay, this tells you that there's something that's not properly fixed, okay? I did not anticipate any problems, but let's see what the issue is. Uh, Now, we don't know, or I don't know what I did not do. Oh, yes, 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 yes. Oh my God. Animate this thing. You can see what's going to happen. Where's that animate thingy? Uh, strip, the strip of film. Okay, first, all right, first, but the reason you don't see it is first you plot it right there, and then you can animate it. Look, that bracket has no idea that there is a pin there that is stopping it from moving into it, okay? So basically, whenever you do uh, analysis of assemblies with multiple parts, you have to create the interaction between them. You can see what happened. I forgot to do the interaction. Basically, you have to say the outer surface of the pin and the inner surface of the top hole, they're connected to each other. There's a connection, and that connection is contact. And the same thing with the bottom one, because otherwise, right now, the bracket is cutting through the pin as if it was not there. That's one issue with the assemblies. You have to create interaction. So let's go ahead and first of all deactivate this. Okay. Now connections are defined here. There are different ways of different type of connections. The one that we use mostly in this course is general analysis connection. See, analysis support. Click on it. It says two components. Well, first component is the surface of the pin. Let me hide this. Second component is the surface of the hole. And notice that the connection has been created here. If you go all the way to the top of the tree, a connection has been created. It would have been a good idea to call this thing connection top of the pin, the top pin and the bracket. And for the other one, it's going to be the bottom pin and the bracket. But I didn't do it. Okay, so do another one. So surface of this, second component, hide that surface of this hole. The second one has, this is what I meant. It's a good idea if I had called this thing top pin, bracket. You can do that later on too, but anyway, that's what I was talking about. But our problems are very simple. I'm not going to, unless I get really uh, forgetful. Here, rename properties, say bottom pin. Actually, this is the other way around, right? Okay, so let's cancel that. Let me do this thing. This is the top pin, and this one I'm going to call it bottom pin. I forgot the other. So this is going to be bottom pin. I mean, if you have a complicated problem, it's a good idea to give meaningful names to these things. Okay. Now, the very fact that you created the connection between them, it means that these are actually connected together. It's like saying that uh, two people are related. That's fine. But if you don't say the relationship, it's not good enough. You have to say, are they siblings? Are they parents, child, parent, etc., or friends. So here, that is done in the distant or the connection property. See, we created connection, and now we go here, connection properties. One of them is called face, and this is the kind that we want, face. You click on it, slider, no, contact. That's what you want. This is slider, means that pin can go in and out like that, but this one is contact. One cannot penetrate the other one. So what I have to do is select the top pin, and you have to do this multiple times. And then again, where's that contact? This the one? Yeah, contact. Bottom pin. It put these things here, and the pins are hiding because when I created them, I hid them. Remember, I created these connections, hid them, so it is in the hidden space. If you want, you can get it from here. If it's bothering you, you can bring it in the front. You don't have to, because once you run it, it's going to fetch it from that screen. And let me, before I run it, I save everything. And now we're going to run it. You see that the pin will not let bracket go through it. Make sure you change your scale. First of all, let's go ahead and here, deform shape, activate, and change the scale here. See that this is scale? We wanted Catia to be interrogated. This is why uh, we said show it to us. So I know it's flying to infinity, but show it to me. But there we are. Okay, so now you can say, okay, show me the animation. Notice that no longer that bracket will actually go through the pin, as it shouldn't. If you want to look at the von Mises stress, for example, I mean, it's so easy to generate good-looking garbage, but anyway, if you want, it's right here. Now, if your main concern is the bracket itself, not the pins, you double click on this contour, on the selection, you say, just show me the bracket, and notice that now it puts the pins away and shows you the bracket. Okay, stress distribution and bracket. As I said, these numbers, although you can look at it, but be very careful to take these as literally as good, because we don't know the effect of the mesh. We don't know, so pretty much that's it. All right, that take care of activity number one. Uh, I have talked more about this particular problem when we had the face-to-face lab. Okay, for example, in the class, I did it also without using planar symmetry, uh, but don't do it on the test, because the test says use all applicable planes of symmetry and use the most appropriate element.